Objects are everywhere, you see them each day. The computer you're using? That's an object. Your coffee mug? Also an object. See, in the world of computer science, we use these things called objects to model real-world things. Object-oriented programming, or OOP, is a super cool way to write computer programs by organizing code around these objects. Java is a popular language that uses OOP. It's like building with blocks, but these blocks are pieces of code. Think of it like building a house. You don't build a house all at once, right? You start with a blueprint, then you lay the foundation, build the walls, and so on. OOP is the same way. We build our programs piece by piece. Java lets us define the blueprints of these objects and how they interact. These blueprints are called classes. Pretty neat, right? There are four main ideas, or pillars, that OOP is built on: encapsulation, abstraction, inheritance, and polymorphism. Think of encapsulation as putting all the important stuff inside a capsule. It's like hiding the technical details of an object and only showing what's necessary. Abstraction is similar. It's like a simplified view of something complex. Think of it like the button on your TV remote. You don't need to know how it works, just that it changes the channel. Inheritance is like passing traits from parents to children. In OOP, one object can inherit properties and behaviors from another object, making our code reusable. Finally, polymorphism lets objects take on many forms. It's like a single object responding differently depending on the situation. These four pillars work together to make our code organized, reusable, and easier to maintain. Let's look at some simple Java code to see these principles in action. Java / encapsulation. Example: public class dog, private string name, private int age, public string get name. Return name, public void set name string name, this dot name equal sign name / other methods. In this example, the dog class encapsulates the dog's data, name and age. We use methods to access and modify this data, keeping it safe from outside interference. Java / inheritance example: public class animal / public class dog extends animal //. Here the dog class inherits from the animal class, gaining all its properties and behaviors. Java / polymorphism example: public class animal, public void make sound, system out.println, animal sound. Public class dog extends animal, at override public void make sound, system out, println woof. In this case, both the animal and dog classes have a make sound method, but they produce different sounds. This is polymorphism in action. These are just basic examples, but they show how OOP principles work in Java. Section 4. Benefits of OOP. So why is OOP so great? OOP helps us write code that's organized, reusable, and easier to maintain. It's like having a well-organized toolbox where everything has its place. Reusability is a big one. With inheritance, we can reuse code instead of writing it from scratch every time. This saves time and effort. OOP also makes our code more flexible and adaptable to change. Plus, it makes it easier for teams of programmers to work together on large projects. Overall, OOP is a powerful way to write software, and Java provides excellent tools for building robust and scalable applications using these principles. Section 5. Conclusion. Object-oriented programming is a powerful way of thinking about and writing code. Java, with its object-oriented features, provides us with the tools to build amazing things. By understanding encapsulation, abstraction, inheritance, and polymorphism, we can write code that is well-organized, reusable, and easier to maintain. So, there you have it. OOP might seem a bit tricky at first, but once you get the hang of it, you'll be building complex programs like a pro. Keep experimenting and, most importantly, have fun with it.